right, so we're moving on in our chapter 6. This is 6-7, finding the inverses. Again, just like yesterday, a lot of old stuff. We're just going to kind of do it in a different way, which is nice when it's not brand new math things. It's just building up on what you already know. There's a couple definitions. There's a relation and there's a function, okay? They're both technically an ordered pair. The difference between the relation and the inverse, the relation and the function, is that the function is only a function if your x's do not repeat. An inverse relation, to define the inverse of it, all you do is switch your x and y's. After you switch, if your x's still don't repeat, then you call it an inverse function. But if you've switched them and some of your x's end up repeating, then it's just an inverse relation. So relation, x's repeat. Function, x's do not repeat. You figured out functions and stuff. You did it from graphs before, like you did the vertical line test, right? And if it touched that line more than once at the same time, it wasn't a function. We're going to kind of bring that back a little bit today too. Y'all doing okay? Yes, you quiet. Did you forget your glasses today?
I can see like the outlines of it, so I'm like hoping what I'm writing is true.
Okay. If you need to take a picture, I understand today. You can take a picture and blow it up. Okay.
As long as I don't sweat,
you have my permission to take a picture and zoom in if you need to. We good? You got them? So the first way we're going to do it is with the table. So the first one I've already given you some values. Oh, sorry, I skipped something. All right, inverse of a function will not always continue to be a function. Sometimes the function, after you inverse it, it changes to a relation. Vice versa. If it's a relation first off, which means your x's are repeating, and you inverse it, it could turn into a function. Okay, so don't think if it stays a function, it's always function. Not true. Sometimes it can reverse. Same thing if it starts off not a function, doesn't mean it stays that way. When we switch our x's and y's, we might get a function or mess it up along the way. Okay, so there we go. That's the first table you already have there. Looking at that, is it a function or is it just a relation? It's a function if your x's don't repeat. So is it a relation or is it a function? It is a function, okay? Beautiful. So above it or below it, I want you to write function. So above your table or below your table, write function. So find the inverse. What does the definition say for inverse of relations? Just switch the x and y's. So that means 0, -1 becomes -1, 0. You're just flip-flopping them. So after you flip-flop them, did the function stay a function or did it switch to a relation? Still a function. Yay! Remember kind of doing this stuff a little bit with in Algebra 1? Maybe? You didn't do the inverse part, but you looked at a table and you should be able to say function or not function. How about you do the next one? So label that first table as function or relation, then do the inverse, and then label it again. Emily, is the first table a function or a relation? It is a function. Good. Once we switched it over, Jimmy, function or relation? Relation this time. Because what ended up repeating? The x's of -3s. Good. Feel good about it? Like tables? Cool, now we're done with tables. Now we're going to go to actual equations, okay? There's 4 steps to taking the inverse of an equation. Step 1, you replace the f of x with y, because f of x represents function, so make it a y. Then you're going to switch x and y for step 2. Step 3, you're going to solve for that new y. And then step 4, you're going to change your notation back, but instead of f of x, it's function inverse notation. So f, that -1, it's not an exponent. That's the inverse notation. So f of x shows your original. Inverse of f shows the inverse afterwards. Did you just say you hate fx? Such an odd hate.
I hate f of x.
F of x?
Why don't you say y for everything?
Because some things are functions and some things aren't. F of x shows you it's a function. All right, so with 3x plus 2, first thing it says, make it y equals 3x plus 2, right? Switch the x and y. Now solve for y. Do we agree that when I get y by itself now, I'm doing inverse operations?
Yes.
Yeah. So instead of adding 2, I'm going to subtract the 2. Instead of multiplying by 3, I'm going to end up dividing by 3. That's why we do it this way, to get the inverse function. So subtract my 2. Oh, I never have enough room. I remembered. So it becomes x minus 2 equals 3y. Then we will divide that 3 out of it. We're left with x minus 2 over 3 equals y. Change that y to the inverse notation. So my original function had plus 2. My inverse function has minus 2. Math magic. My original function multiplied by 3. Inverse function divided by 3. Math magic. See? Does it make sense? To find the inverse, you have the inverse of the original operations. Questions? All right, do that one. We have f of x equals 2x plus 8. It's all you. All right, so we should expect the 8 to be what in my answer? It should be a minus 8, right? And then we should also have a divide by 2. Hold that 4. I know what you're getting at. Wait for it. So subtract that 8. Divide by 2. Now, my friends who said 4, you're not wrong, but you got to be careful, okay? Because if you just say x minus 4, that's not the right way to write it. Remember, both pieces are being divided by 2. X divided by 2 is just going to stay 1/2 x, right? There's a 1 right here. But negative 8 over 2, that can turn into a 4. So if you simplify, you got to remember both pieces are being divided by 2, not just the 8. Okay? So if you take it that one step further, make sure you take it to there. And that's our inverse.
But you don't have to take it to that.
You don't have to. I will, just because that also kind of shows you what kind of graph you're going to end up with. Like, I can tell that that's a line, right? So, and we're going to graph them in a little bit, so it just helps seeing it. But not required. You good? All right, how's the next one a little bit different? X is squared. Oh, this one is a function, by the way. That was part of the question. Is the inverse a function? Yes, because we just talked about it. Changing it that way, I saw that it was a line. So that helps me answer the question that yes, it is a function. All right, my next one. Let's see here. This will be y equals x squared minus 1. Switch x and y. I'm going to have to add the 1. Oh, no. How are we going to get y by itself?
Square root.
So smart. Woo! Square root. So I'm going to get the positive and negative square root of x plus 1. Because square roots, remember, they have positive and negative answers. Okay. This one is not a function. We're going to find out why here in a second. A hint might be what we did yesterday. Like if I asked you for the domain of 1/2 x minus 4, what would you have told me yesterday? The domain of a line. What's the domain of a line? Negative, positive, infinity. Yeah. What did we say the domain was yesterday if we had a square root going on?
0, bracket 0, negative.
Yeah, but if they had to only be positive, right? So 0 to infinity. There was a rule there. So it's interesting how the line didn't have a rule. The square root did have a rule. The line becomes a function. The square root says not a function. Might be connected.
What?
Just maybe. I'm going to show you.
Okay.
It is. I'm going to show you how. Okay, so on the back, we're going to actually graph what we just did. Okay, so the x squared minus 1, we're going to graph that first. So we're going to plug in some x values. Let's plug in negative 2, 0, 1, and 2. When we plug negative 2 into x squared minus 1, that becomes what? 4 minus 1, so 3. Plug 0 into my function, that becomes 0 minus 1, so negative 1.
It's because the y's are really the same on the inverse. Or if you inverse.
Maybe. Yes. Mm-hmm. Stay with me, guys. So I want you to go ahead and graph those points on the graph below it. What kind of pretty picture should you get?
A circle, a U.
A parabola.
Yep.
Yeah.
I knew it was one of those.
Yep, you should get a parabola when you plot those points. We're going to graph the inverse on the same graph. So the next one, if you have a different colored pen, you could use that to show the different one. You could do a dashed line when we graph it, or a darker line, or you can just label it. One's f of x, one's f inverse. Just to show where they are. All right, we had to plug values in to get this first parabola. Am I going to have to plug values in to get the inverse? No. What do we got to do? Just switch the table. So when I go to get my inverse, I'm just going to flip my x's and my y's. And we already figured out what the inverse equation was from before. Plot those lovely points. We're going to get a pretty picture. It's almost a parabola, but it's laying on its side. Which looks something like that. To switch x and y, what we're doing on the graph, we're actually reflecting the graph across the line of y equals x. So 1, 1, 2, 2, 3, 3. The graph is actually being reflected over that dotted line. That's what it means to do the inverse, to switch them. So my green becomes the blue. So this was our original right here. And then this blue guy was the inverse.
It doesn't pass the test.
Yeah. See how when it gets flipped to its side, it doesn't pass the vertical line test?
If that line, since you see how the lines are like this.
See how if I draw a vertical line, it's touching it more than once? That means my sideways parabola is not a function. It fails. If you graph the square root of x plus 1 on your calculators, it's just going to show you this top piece. It won't show you the bottom piece. So if you just have the top part there, it works. But taking the whole parabola and flipping it over, it's not a function. So does that make more sense why it's not a function?
Yeah.
Okay. Because we said that the x's had to be bigger than 0. So we flipped them. Y's had to be bigger than 0. In this case, they're not. Okay. I lost some of you with that one. When you do the inverse, the domain of the original becomes the range of the inverse. Fun fact, just a side note. Okay, we'll get into more of that later, I promise. So, would the inverse of any parabola be a function? No, never. Okay? If we ever have a parabola and I ask you to find the inverse and then ask you if that inverse is a function, you should always say no. It's never, ever going to happen. It will start as a function, but once it gets flipped, no longer a function. Okay? My next one, 2x plus 8, that was from the front too, right?
Yes.
Yes? So let's check this one. Do you think that we said that its inverse was a function? Let's see why. All right, so let's fill in the table. Let's see here.
We're going to graph right off the bat.
Well, you could. It's a line, right? Start at 8, slope of 2. You could. We're going to make a table, though, so that way when it comes to graphing my inverse, it's a little bit easier. Let's use x values of, let's do -3, -2, -1, and 0. Still in that table. So if you plug in -3, what comes out of it? Plug in -2, what comes out of it?
4, 6,
Plug in a -1, what comes out of it?
6,
Plug in 0, what comes out of it? 8. Good. So see how I kind of made both tables at the same time? That's nice and easy. We already found the inverse of this function on the front. That was the one where it was 1/2 x minus 4. So I want you to plot the points of the function and its inverse, and let's see what happens there. All right, so they're both lines. Remember that dotted green line, that's that line y equals x. That's what we're technically reflecting our graph over when we switch the x and the y. So after it got flipped over, did my line stay a line? Yeah, and lines are always functions. So that's why it passes our vertical line test.
Wait, does that line, the green dotted line, always run through the origin?
Yes, because since it's y equals x, it goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Whatever your x's and y's are the same, that's where it's crossing over. Like if I folded this on that green line, the red and blue would lay on top of each other. We good? We're going to get into more transformations on Thursday and Friday.
Yeah.
Woohoo! You good? Yes? Questions on this? So if I do the inverse of a line, will it always be a function, or could it switch?
No.
It's always going to be a function every single time. So parabolas will always turn into not functions, right? Relations. Lines will always stay a function, no matter what. Okay, last 3. Here we go. Let's find the domain of the original and the inverse equations. Okay, so my first equation is 3 minus 7x. Yeah.
Yeah.
Yeah, because what made you say that?
Because it's nothing special about it.
Nothing special about it. What'd you say?
It's a line.
It's a line.
I don't know.
Perfect.
Because it's a line.
It's it follows the mx plus b. The mx and the b are kind of switched, but it's that same equation. And then yesterday we were looking for square roots, right, or fractions, and that's not happening here yet. So Adam was saying he doesn't see a square root or a fraction, and then Alex noticed that it was a line. Beautiful. So what do we already know about the inverse domain?
That's gonna be.
If it's a line, it'll be that again, right? But let's figure out what that inverse equation is going to be. So it's y equals 3 minus 7x. So switch my x and y to do 3 minus 7y. Then what? Subtract the 3. And then divide by negative 7. So it becomes x minus 3 divided by negative 7. Again, that should make sense. We should see the inverse operation show up, which they did. And we just talked about how lines always stay lines, so we know my domain is still going to be all real numbers. Negative to positive infinity. Questions? All right, my middle guy. What's the domain as is right now? 3x squared. That's a parabola.
0.
Hmm?
Wait, no. What's the domain of that?
Yeah.
Would that be?
Okay, so this is a little tricky.
Would that be?
It's not the square root. It's just the square. So since it's just the square, it's still negative and positive infinity. Remember, parabolas are functions. Okay? So functions usually go negative to positive infinity. But Malik's thinking about what's going to happen after we do inverse, right? Because if we have an x squared, what's going to be the inverse of that? Square root. So we know my domain is going to be something different, right? Let's figure out what it is exactly, though. So we have change that to y equals 3x squared. So that means x equals 3y squared. What do we do? Divide by 3. So we have x over 3 equals y squared. Then we do the square root. There's our square root, right? So it's going to be our function is the square root of x over 3. This extra 3 should not be there. It's x over 3. That should not be there. And because of that square root, my domain changes to what we did yesterday, right? It has to be positive numbers under there. So my numerator has to be a positive number. Yes, sir.
Wait, is it the square root of x over 3, or the square, like the square root of x and then divided by 3, or?
It should be, yeah, you're right, like this. Boop.
So you wouldn't square root it first, you divide it first.
Yep. Does our domain make sense? Because it was under the square root, we need to make sure it's going to be a positive number. You good?
Yeah.
Prove it. Do the last one. Some of you already have. If you haven't, go ahead and do that last one. Maybe. Might be a cubic. I want you to check your answers with mine. Check your domains, check your function. Langston, it was a line, which is nice, because that we know our domain is the same for its inverse. We still like it?
Yeah.
Still not too bad? Yes, sir.
So we have to write both the domains, right?
Oh, okay.
For this. Yep. Yeah, always read the directions. They'll tell you what to do. Like in your homework, it's different for each section. Some of them you don't do the domain. One section of the homework you do the domain. So just whatever it says to do, do it. So tomorrow we'll start graphing them. And remember you have a quiz on Tuesday. Over yesterday, today, and tomorrow. We'll quiz on that because we'll practice tomorrow on Friday also. We'll review everything Monday and we'll quiz on Tuesday.
Is tomorrow hard?
No, we start off nice.
What about the end?
See, y'all can't ask me that. 'Cause I think it's all just fine. I'm the wrong person to ask. I love it all. Okay, homework. I did put the picture up here this time. Alright, so you are page 410, 9 through 35. All of them odd. You will need to graph some of them. Looks like the first and third section you have to graph. Looks like you do domain for the last piece, so just make sure you read the directions, okay? If you don't have graph paper, my suggestion, take your piece of paper, lay it on top of the graph from the notes, and you can kind of trace it. Okay? If you don't have graph paper. We are working. We're not packing up. We're not putting things away. We should be working today.